I think you're leading the call, Fred. This is your
Okay,
baby.
Lee,
Yeah.
how you going today, and what do you feel like say?
You st
Feel wonderful.
You muted. You,
Ooh, I just muted myself. I'm excited. Oh, I'm really excited for Wednesday because I read all the questions and they're all marked in the book. If you haven't looked at them,
We're not doing Wednesday. We're doing.
I know, but I am ready for it and I want answers to every one of those questions. And
you
I'm
should know
hoping,
half of them.
uh, yeah, some
Mhm.
of them, but then again, the opinion of all of us is very important because somebody else could have a really good, oh, Anne's here. Um, very, very good reason for their explanation. And but today I'm excited to find out more about this book. I know nothing of this one. I haven't read anything of it.
Wait a minute, you did a whole assignment on binary
Oh,
numbers.
you're right. I did. I did a great chart of binary. I it's still there.
Yeah.
I did. I did.
Good.
And I got it almost correct. Almost. So you should pat me on the back.
Yeah. Moving right along,
Yes. Now, how are you, Anne? And how are you feeling? And what is your desire to find out today?
Yeah, thanks, Lee. And hi, everybody. Yeah, yes, I'm happy to be here, and a little disappointed because this is me, a hit and miss, trying to get into like opening up my whether it's email or whatever, right?
Mhm.
So I couldn't get into to go through for today. I need help, so I'm gonna have to get my assistant to help me. I don't know what I did this time that I can't get in. I could get in the last time, so this is me. So apologies, but more because I was a bit disappointed not being able to do that. Yeah, and but looking forward to being able to continue on with the book and see where it goes. Yeah, and happy to be here with all of you. Okay, yep. So is it now to Fred or to Steve?
Steve.
Steve.
Steve, okay. Steve, how do you feel and what would you like to take away today?
Yeah, I'm feeling really, really good. I've seen the Odyssey movie twice, once on Thursday, and I saw it earlier today. It's worth seeing twice. It's also worth watching some of the video critical reviews by all the self-made experts about classic, Western classic literature, and to see all the controversy and watch life move ahead. It's a really powerful movie, and I very much enjoyed it. I cried more the second time than I did the first time because there's more in it actually about Odysseus. The way Christopher Nolan interprets Odysseus's change of heart and gr growth is just really profound. So whether it's accurate or not, that's another discussion, and we could talk about that. But I'm very excited about getting into this program in the universe. I wish I'd spent more time with hexadecimal, but I understand the binary really, really well. I'll work on hexadecimal on my own. I think it's important to do that. Also, I listened to a great audio this week on integrated information theory. So they just keep coming up with stuff. So I'm very looking forward to how this goes because this is the basics, and I'm very excited about it. Thank you, Fred, for bringing it up. We anticipate that Joe is out of town. Manu has stayed up late watching the football game and he won't be joining us. And Richard says he'll be a little bit late, so he'll join us as we go. Fred, how are you feeling and what do you anticipate for today?
Did you say Manu is watching the football instead of being with us? And
Yes, I
he
did.
he had something to do this week, which is explain to us the decimal, digital, and the decimal, the binary, and the hexadecimal.
He sent out a chart and it was quite inspiring. I used his chart and made some assignments for myself and for Lee, and we advanced markedly on binary. We did not make any progress on hexadecimal, and I want to see the result of FF, Fred.
Yeah, it's not my job. It's sorry, it's Manu's job.
It was
No,
Manu's
I
job.
mean, come on. We've got to hold these guys accountable for their
That's right.
commitments.
Exactly right.
Otherwise, on Wednesdays, when I say I worked on 60 questions, somebody comes up and say, "Oh, we're going to share all that." No, we're not. I claim it and I take responsibility for it.
Good. Have you counted the? Never mind. I was going to say.
No. I'm of the opinion that Kiyosaki is correct. We can go as far as our context is tight, and loose context, lose lives. To paraphrase the Navy, which says loose tongues, lose ships.
Uh-huh.
So no, we've got to hold these guys accountable. So let's talk about the Odyssey.
Yeah, yeah.
If you think it's appropriate, I'm happy to discuss it. I've watched a couple videos, but I'm really interested. What's your question?
Okay. No, I think we should move along.
Okay.
But since you worked on digital and maybe a little bit hex, is that useful for Anne to hear what Lee would have to present about transforming
Sure.
from base 10 to base 2?
You
How
want to
about
talk
that?
about it, Lee?
Sure.
Okay.
Yep.
So Lee, you've got the floor.
All I know is that when I started, it was easier to know what to do. The first, because of course it was a lot of lines like this going, up, down, across, and then the perpendicular. Did you throw it away?
I did, I threw it away.
How dare you?
Yeah.
That's not nice.
You can reconstruct it.
But I'll tell you, it became more difficult halfway down or before halfway down. Because I was still thinking in my math instead of what I was learning. If I had thrown away my math and just did it as a game, maybe using
Game theory.
game theory. 1 0 1 1 1 1 1 at the end, all the way to the right, meaning that that's the beginning. If I had done it that way, then I would have gotten it a lot faster, I think, at the bottom of the page. It was difficult to learn, and I need to do it again. And I promise you I will. And you got to find my papers.
Yeah. I can't put it blank, but it.
Okay. Yes, I need to look at the first one and see where I made the mistakes. It didn't make sense to me. Why? I liked the way I was doing math, but my son kept saying, "Why are you doing that one? Why don't you go to what was the other one? The one that we're what? Hex. He said, go to the hex. That's better. and I was anxious to get to hex, and I never made it. So that's all that I can say about it. I did do the program, and I went down all the way to what, 26? Did it go down to 26?
Not much further than that. You went to a square, I think you quit at 256.
256. Okay. 256. I got to 256. So I thought I was doing pretty good.
And I had a comment.
You have to.
May I comment? Hey, I'm gonna share you the chart that I did, which is our follow-up assignment. And what I discovered, Fred, was that the squares, understanding where the squares were a really big break. As we came up the chart here, let me see if I can make this bigger. And so as we came up the chart, knowing when this break occurred, it was okay to say, okay, we're moving to when do we start a new one out here and end up with zeros across here? It was important to understand when we hit the square. So what I was going to do next in this chart was do the two squared to the third to the fourth to the fifth to the sixth to the seventh, and bring that out and focus more on the squares. I thought the squares of these numbers were a big clue as to when to make the break. Anyway, I thought that was profound. So as this chart built out, it was important to see how many times 150, the 512. I found the squares were just really important, and I'm not communicating very well at all. But here we went down the side, and so on the next assignment, I went to 1, 2, 3, 4, 5, then 10, 11, 12, 15, then 20 to 25, and then 40, and then I started picking random numbers just to see if I could do something at the bigger digits, And I purposely went to 1024 because that was a number we discussed, and it was kind of like a Bucky number. I thought might be fun to show that in binary. So that's where we went with it. This sheet we haven't done yet. So I don't know if that's worth sharing, Fred, but that's what we did. I'm complete.
Okay. And are you satisfied with this explanation?
I'll have to go back. Okay, I get the explanation. I'll have to go back to catch up with I think the session. Then it'll make a lot more sense, and also watch the video. Yeah.
Fred.
So thank you, but thank you for that.
Okay. Is it important to do that, or is it just should we move ahead? I thought go ahead.
I think it was important because Manu had decided that he would do that.
Yeah.
But since he's not there, we can, and since many of us are not there, we can push it to next time and ask Manu to go
That'll be
ahead
good.
with the explanation.
Yeah, I'll make sure. In fact, I'll send Manu a note and say, Manu, we're looking for your report next week.
Yes.
Bi and hex next week.
Yes.
All right. I have it on my list of things to do.
Okay. Would you like me to share my book?
If you would like, you're conducting and love to have you share.
Okay. I'm going to do that.
Did you know that when someone posts something in the chat, it stays in the record of the chat, but anybody new coming in doesn't get access to any chat prior to when they came into the meeting. So Richard and Manu and do not get the benefit of your slop chat. I just thought I would point that out to you. And you
Yeah, well, that's fine.
Okay,
That's
good.
fine. It's okay.
Okay, good.
They can get indirect information.
Yes, okay, good. If they look at
It's,
the archive, if they look at the recording, the next week's thing.
or maybe we should somehow not adjust the rules, but sort of issue an etiquette guidelines, because I think that would be useful. But I believe that putting one definition for a word that is important to make sure everybody understands at the moment we explain something. I think using this in the chat is good. Or adding some information sent out. Okay, we talked about this, I found that, and mostly it says this, and that maybe you're interested in. Might be useful, but sending links to full AI research and or placing in the chat stuff that we don't have time to read and still be together with the group. I think this is a little bit abusing the chat tool. So yeah, I think we should have an etiquette sort of
Well, I
the
like
same
the
way.
idea of building a lexicon, but the idea of
Yeah.
managing it is kind of tough, though. I would volunteer to attach it to every call, except I'm still haven't figured out how to put the AI summary on there, and I'm just barely hanging by my teeth with catching up with everything on that. So
The AI summary, you receive it by email, don't you?
I don't receive
Have
it by email.
have you talked to the support
No.
service?
I haven't talked to the Secret Service.
That's the way to do it. I can't walk you through it. It's too complicated. It's
Good.
not difficult, but it's Zoom app. When you dig a little bit, you find 3 or 4 or 5 layers of different generations of the app. There's like 20 different ways to do the same thing. The menus don't match with each other and all that, so it's a real mess. But talking to the support service, they're very helpful. You go through the chat. There's a chat on the support service, and they walk you through how to set up to do the setup, all the parameters that you can set up, so that you get exactly what you want.
Okay, I put that down as my
It's
second
working pretty
priority.
well. Ever since I did that, I get my recording start automatically. I get my AI report by email sent to me each time after each call. It's really useful. The only
That'll be
thing
my
that
second.
happens, but there's no fix to that except I have to remember it, is that when I wait and I stop the recording, it doesn't restart automatically. So sometimes I miss a recording when I manage something.
So do you record on your end as well as
No, I
the?
cannot. I
Okay.
cannot. I'm not. Only the host, the main
See,
host, is the only
I
one
set
that
up
can.
my thing so that if anybody wants to record, they can. I do think it prompts me and says that someone wants to record, but it's a totally democratic Zoom. I did not set it up as to control everyone. That's why anybody can share anytime they want and just show how rude they are.
Record.
Yeah, it'll give you the opportunity of recording to your computer, to your device.
You're correct. You're correct. I can record.
Good. See?
No, I need to request. I need to request to the host to record
ahead.
to the client.
And
No. You have the recording on.
well, it's recording to the cloud, but you should be able to record on your side as well. It's recording to my cloud,
Yeah,
to
but
my dashboard.
yeah, but I don't want to do that. I have access to it once you post it.
Okay, you do it whenever you like.
I
Very
don't
democratic
really
on your
want to do
side.
that.
All right,
I
good.
don't. I already have too many videos that
Me too. Me too.
I need more than one lifetime to go back to all that.
It's hard to go to sleep at night. There's so much information out there, and I'm so frustrated with AI because a couple of things are really good. Like you've enjoyed I think you said you enjoyed the fine. I've enjoyed some of the Feynman AI programs because they consolidate him and they focus Feynman. You've enjoyed Susskind, I think, and
Yes.
I have really liked um, Carl Jung. Woo! The way they've concise some of his messages are very, very, very good. It's a lot more poignant
Yes.
than Carl Jung, who was kind of scattered,
Yes.
everywhere. So
Yes, but once again, if you hear something interesting and then you just post, okay, there's a link of the AI. I listened 30 minutes of Carl Jung, or I listened 30 minutes of Feynman,
yeah,
without saying, okay, it's at 4.35 minutes. For 2 minutes, he talks about how everybody is only made of information, and this point is very important.
Yeah.
This is, if you just throw us 30 minutes to listen to without telling us what is it exactly that we should
Yeah.
look for, then
Agreed.
it's that's slop. Then that's
I will
slop.
say
But if
that 80% of the time, I'm going to say this, when I send out a video, I say of interest at, running time 22 minutes, 42 seconds in. That's hits a topic. And a lot of
Yeah.
times those have chapters in them. Some of them have chapters in them. You can say chapter
Yes.
this and chapter that. So
Yes.
yeah, I agree with you. I'll listen to Feynman, Susskind, and Jung. The others are very frustrating to me.
Yes. Yes. So I find Susskind extremely interesting. He's really asserting things maybe a little bit further than what we know with precision, but he asserts it in a way that it allows you to crystallize your ideas. And then you can add nuance about it, but he tells you, okay, this is this, and this, and that. And it's 99% correct, except some nuance that he glosses over, because he wants us to get solid ideas about what's going on, and then the nuance can come comes after. It fits me well. It fits me well my way of learning.
Me too.
Okay, let's go to the book. I'm going to share my page. Share. Where is it? Programming the Universe. This one.
So let me, as you get started here, the big stuff, Anne, on programming is on page, like critical from pages like it starts at 18, 19, and 21. It really goes into, it starts explaining ASCII. But those are really good pages, and that's what I'm going to review so that when Manu does his report next week, I'll be on top of it and can learn something about hex, because there isn't really much about hex in this book. Am I correct, Fred?
That's correct.
It's mentioned.
Hex is, I mean, it's unwieldy to try to manipulate binary, because you end up with a kilometer-long strings of information. So, but that's you can't read it. But if you read 8 digits of hex, and then you can remember that.
Yeah.
8 digits is not very difficult to remember. You can remember that, and this compresses a binary, a very long binary string.
Yeah.
Yeah.
Very
That's
beautiful stuff.
okay. So we stopped at the meaning last time, but I would like to go back to the previous one, which says with only 300 bits, you could assign a unique barcode to each of the 10 to the 90 elementary particles in universe. This gives us a lot of information here. One, it gives us that the estimate of the number of particles, elementary particles, we're talking about atoms here, in universe is 10 to the 90. That's 10 with 90 zeros after. So that's a fairly big number, but it's limited. It's not infinite. And then it says with only 300 bits. And now we can think about why is it 300 bits compared to 10 to the 90? It's because 10 to the 90 is equals 2 to the 300.
Sure.
10 to the 90 in decimal, so that's 10 followed by 90 zeros, is equal to 2 to the power 300, more or less.
Yeah.
Yes?
This is what
That
I
means
mentioned, that the squares, the binary squares seem to be very significant, and this just is pointing it out right there. Right? 2 to the 300 is equal
2
to
to the
10
3,
to the 90.
2
Right?
to the 300 is equal to 10 to the 90. Yes?
Yeah, beautiful.
So that's what allows us to say 300 bits are enough, because with 300 bits, we can represent 2 to the power 300, because each bit has a horse or doesn't have a horse. So every time you have one bit and you add another one, then you have the square of the number of possibilities. Have a
Right.
horse if you have one bit represents 2 possibilities. Have a horse, no horse. So it's 2 to the 1. 2 bits represent no horse, no horse. Have a horse, no horse. No horse, have a horse. Have a horse, have a horse. That's 4. That's 2 to the 2. 3 bits, the same. Have a horse, no horse, no horse, no horse. Have a horse, no horse, no horse. No horse, have a horse, no horse. No horse, no horse, have a horse. Have a horse, have a horse, no horse. Have a horse, no horse, have a horse. No horse, have a horse, have a horse. Have a horse, have a horse, have a horse. 8. 2 to the 3. I will not go to the 300. I don't have enough fingers.
Wow. Thank you.
Okay, so you can see the link there. 2 to the 300 is 10 to the 90.
Yeah.
Well,
If
thank
I-
you. Yeah.
This is the reason why I said that when I was, hey, Fred, I'm going to steal your screen here.
Go ahead.
This is
go
the
ahead.
reason why I said that the powers of 2 were pretty significant, because that tells you what the break is. So as you go from, and the way that it worked, and Fred, you can correct me if I'm wrong here, and I could set us up a string here so this would build all by itself. But if we go, it's the number of zeros. So let me see. So 2 to the power of 0 is 0. Okay, now help me understand this, because it isn't. It's I got to move this. Hang on a second. So it's like this. There we go. Is that right for? Oh, maybe not. This is right now. That's right, isn't it? And then let me see.
What's the second line?
This is this is the decimal. This is where it splits. So if I'm building a binary code here, 0 is 1, and then 1 is 1 0.
What is the second line? What does it mean?
This second line here,
Yes.
that's the somehow that's the binary table right there. It goes from 1 to 2 to 4 to 8 to 16 to 32 to 64 to 128 to 256 and 512. So that's
Okay, so 2 to the 0 is 1. So 2 to the 0 should be in column J.
okay. 2 to the 0 is 1.
Yeah, that's
And then
correct.
what is 0? That's just a 0. I see. So then this would be
That's-
1 0.
That's nothing. And that's the number of bits, actually.
This is the number of bits. Line 2 is the number of bits. That's the number of bits, right? 32 bits. Yeah.
Hold on. No. It's not the number of bits. The number of bits is the exponent. 2
Okay,
to the
it's up
0 is
here.
0.
Okay, good.
Yes.
And so this is right. 2 to the 0, 2 to the 1, 2 to the 2, and then it'll be 2 to the 3.
Yes.
And then it'll be 2 to the 4, etc.
Yes.
I'm going to build these out here. This is the part I wanted to look at, because I found it to be real helpful. When I was coaching Lee, it became obvious that when we hit the next power of 2, that's when we added the 1. And one way
Yes.
to calculate it is you like take the number you're trying to reach and you figure out where the biggest square is, and what's left over will tell you that you have to move to the next number. I'm not saying that right, but that's what I found.
Okay.
This is 2 to the 5. Oops, sorry. Wow, that's interesting.
So,
wants to do. Go ahead.
so now what the column on the right?
That is weird. What's the call? I don't know what I just did. The column on the right was the problem. This is the create a binary code for this number. Oh, I see. I was putting crap in down here.
Okay.
So if
No, that's fine. That's fine. That's
Yeah.
okay. It's okay. It's okay.
Yeah, this was the problem
So,
column.
okay. So you've got to suppress column K.
Well, what I was going to do is I need to
You
suppress it
don't
completely.
you don't need column K. You can erase the zeros there. It's the column K is not useful.
Okay.
Okay. Now, if you want to express 0 in binary, you have to put a 0 in column J.
Hang on a second. I'm giving myself a problem. Why didn't that do that?
It's okay
Here we
though.
go.
You
Okay.
can enlarge K and then you can see no, now you can't see
There
anything.
we go. I just want to. So this column is the problem column down here.
No,
Yeah.
it's not a problem.
Well, that's
It's
I
not,
see that as the problem.
it's not a problem. Now, what you can do is you want to express 0 in binary.
This is a decimal value. This is what this should be, right?
Yes.
This is the decimal value. And okay,
Okay. Now, if you want to express 0 in decimal in binary, you will have numbers that must appear in column A to J.
must appear in column J. That's right.
No, no. Now you have a block of 10 digits to express your numbers. So you have to have numbers that appear in column A to J. And we will consider that an empty column is 0 so that you don't have to fill everything.
We'll assume that an empty column is
An
zero.
empty, we will say that an empty cell is 0.
Okay. I'm
Okay?
sorry, I don't understand what you just said. An empty set is 0. What do you mean?
An empty cell, a cell.
Spell that word.
Cell, C-E-L-L. Cell number
cell.
B7.
Okay, good. Yeah.
Cell. If it's empty, if it's blank, it means it's 0. Yes? So you don't have to fill it up all.
I see. So in other
Okay?
words, putting in the 0 as a space holder is a waste of time? No, because
No.
yeah.
No. It's not a waste of time. But
Okay.
it's important to give a value to blank cells. Otherwise, you will always wonder whether it means anything or not.
Right.
Because each cell is 1 bit, and 1 bit contains a horse or no horse.
There
Has
you
a
go.
horse means 1. Has a horse is 1. Has no horse is 0.
Right.
But it has to have something. So blank is 0. Yes?
Yes.
Okay. Now, if you want to put 0, there, that's correct. If you want to put 0, then you put 0 all the way, and especially 0 in the column J. Okay, you want to do it and explain to us?
Well, no, I was just building it with my logical, hoping that
Yes,
I did
but
right.
yes, but I was trying to have everybody follow it. But if you do it ahead, just explain it as you do it.
Well, no, in fact, I haven't, I think it'll be helpful if I actually understood what you said and followed your instructions, and it might help. And what is important here is 2 to the power of 1 is 2, and in binary, that's 1, 0. Do I have that right, Fred? In other
Yes.
words, 2 to the power of 1, there's 2 to the power of 1 right there. That is a, and so this is the decimal value here. And what we're doing is over here, we're converting it into a binary. So 0, as Fred is saying, and Fred, then I want you to take over, but I'm going to repeat what you said up to this point. You either have a horse in the box or you don't have a horse in the box. So with zero,
Yes,
there's
I
no
think
horses.
I changed my mind. Maybe you fill up everything with zeros.
To start with, I should fill the whole start with zero.
Yes,
I can do that really fast if you want me to do that. Is that what you want me to do?
yes, please
All
do
right,
that
here we
really
go.
fast.
Whoops, too far. There we go.
That's
So
a
we're
lot of
starting with
zeros.
zero values everywhere, right? Is that what you wanted me to do, Fred?
Excellent. Now you fill up. Now you fill up. Now you fill up. But let's ask Lee or Anne to do it. How would you write zero, Lee?
Zero.
In the first line with a zero in the decimal column, how would you write? Would you write zeros?
And the zero.
It's already zero. Yes, that's correct. It's already zero.
Right.
The whole lot. We're looking at the whole 10 digits.
Yeah.
Okay, it's already zero. And how would you write one?
Let me think. How would I write one? Wait, just now I could see it. One would be the column is you have a one there. Yes, the first column you have one.
Yes. Okay,
Yeah.
that's one.
Yes.
Correct.
These
How
are
would you write? How would you write two?
so here's the value for two.
Mm,
And that means there's one. It's two to the
And-
power of one. It's right there.
two will be 1 0.
Yep.
It's correct.
Four will
And
be
Lee, how would you write three?
3 would be in H.
How many
Oh,
two? How many twos are there, Lee? In the number 3, how many twos are there?
1.
Okay, good. And this is the 2 column, right?
Yeah.
So I put a 1 there, right?
Yeah.
All right, good. So there's in the number
And-
3, there's 1, 2, but hey, is there something left over?
Yes.
Aha. And so what value would we give that? There's 1 left over. Is it a horse or not horse? Wait a minute, there's 1 left over. Is that a horse or not a horse?
So horse.
All right, so then we got to put it someplace. Okay. That's the way we kind of went through it.
Yeah, we keep going. And how would you write four?
it would be under H, put a 1 there. 1 0
Very
0.
good. Yeah, good for
Yeah.
you. Because there are 2, there's 1 4. It's 2 to the power
The
of
power
2.
2.
So that means there's 2 zeros to the right of that 1. That's what I deduced as I was doing this. That's why the powers of 2 became very significant for me.
Mm.
And Lee, how would you write five?
How many 2s are there in 5, Lee?
There's 2.
Let her figure it out. She knows.
2. So go to H, 1, and 1 or I be 1. And a 0.
Okay.
That would be six.
That's 6.
Because
Oh,
how many 1s are there?
there's 1.
See, there's 2 2s, that makes 4, right? 2 2s is 4, leaves 1. So how many 2s are there? There's only 1 left. How many 2s can there be? There aren't any 2s because there's only a 1, right?
Yeah,
All right, so that has to be
Steve,
0.
Steve, I let you keep going. I've got to go close my window. There's a big wind and rain coming.
okay, good.
I'll be right back.
All right, good. And so that leaves a 1 left over, right?
Mhm.
So in the number 5, there is 1 4 and 1 1 and no 2s.
Yep.
Yeah. So do you got the principle? We could do now. See, I skipped to number 10.
Yep.
So in number 10, how many 2s are there?
Three twos, which means under column G, there's 1, 1, 0, 1, 0.
So there are 3 twos.
And one out. So that's 1, 0, 1, 0. So under I, another 1. Column I.
There 1 0.
Yeah.
So there's your 10.
Yep.
Because there
Wow,
is
this
1
is so
8,
clear. Oh my God.
there's
Thank
1
you.
8 and there's 1 2.
Yes, that makes 10.
8 plus 2 is 10. Right on. And now we have 11. So we already know what 10 is, so we can cheat. Fred isn't here, so we can cheat. We already know that 10 is 1 0 1
Back.
0. And
I
all
heard
we have
that.
to do. So all we have to do now, we know what 10 is. There's only 1 left over, so we can go to the 1 column and stick a 1 in there.
Yeah.
And now we have 11. Okay, Lee, 12.
There are
How many 8s?
1.
Aha. And what does that leave? How many horses does that leave?
4.
4
It
horses.
would be, a 4 would be 1
Aha.
and 0, 0.
Okay. Now that Fred's back, he can coach us and make sure that we're not screwing around with anything. I'm going to get rid of the page view on this thing. I like page view because it like helps me keep my margin going, but I'm going to switch over to normal view as soon as I can find the damn thing. Here it is, view, normal. So that means we don't have to deal with that page thing anymore. Okay. Now, Fred, what I noticed was there's zeros all the way across here, but I found them to be kind of annoying and actually was better for me to leave the damn things off.
Mm.
What do you think about that, Fred? Do you like the zeros there?
I think what happens with the binary is that usually it's counted as a counter where you have so many stalls for horses visible. Usually it's 8 or 16. Sometimes it's 32. It's called a register. And computers used to be 8-bit computer. You remember that? Then we had 16 bits computers.
Yeah,
And then we had 32 bits computer. And then we have 64 bits computers. And this is the size of a register. And this corresponds to how many instructions the microprocessor can deal in one time. It doesn't deal with 1 and 0. It deals with a register, full register of 1 and 0s at one time.
I see.
So right now you've got 10. 10 is quite unusual. You should have 8 maybe, and 8 would be the unit that you would use. So you would probably need to see 0, 0, 0, 0, 1, 0, 0 in order
an
to.
8-bit computer, you'd see all the zeros, is what you're saying.
Yes.
Yeah. So all of those would be blanked in because it was an 8-bit
Yes.
computer, so it would show 0 values. I gotcha.
Why is it important? It's because you have to be able to represent negative numbers.
Mm.
And usually the first bit in the register, I mean the one most on the left, it's either 1 or 0 depending on the sign.
Really?
You have to assign, you have to use one of the bits in order to represent the sign. And then when it's negative, the following usually is inverted. That means each 0 means 1 and each 1 means 0. But that's going too much into the details there. So you want to be able to think about that as registers of 8 or 16. But let's stick with 8 or 4. We can make it like 4 registers.
So
because
we
that's
have a
where
4-bit computer.
Yeah. It doesn't matter. It's just a matter of getting your mind used to this idea of registers.
Could we do 8-bit then? Because 8-bit would give would stretch us a little bit more.
Yes, well, we're doing 10 bits right now.
Right. Yeah. So make it 8 instead of 4.
Well, if I'm understanding Fred, if he was talking about if your computer was an 8-bit computer, you'd have to use multiple units of that configuration in order to handle anything bigger than 5 in our chart right here.
No. 8-bit computer means 8 positions for each for 8 horses.
Yeah.
Okay.
That means
That
up to
is that means 8 columns. J, I, H, G, F, E, D, C. That would be
yes.
your 8-bit register.
It'd be up here. GC. What did you say again?
A and B are not. A and B would not be accounted for.
Right.
You would go to 2 to the power 7,
Yeah.
and that can be encoded on 8-bit.
Okay. Well, this is a perfect
makes-
time for me. My mind just got blown. So we have 2 people joining us. Fred, if you'd like to acknowledge those folks and invite them into our hellish game.
I can see only one. So who is it? Oh, Richard.
Okay,
is it?
yeah.
All right, Manu.
Manu has joined us too.
Manu, you let us down because you were supposed to teach us how to count in decimal, hexadecimal, and all that. So we've been waiting, and then we decided that since you dropped the ball, we'd do it ourselves. So how are you feeling? How are you feeling? And what is your desired takeaway today?
I was thinking of you. You know, I watched half of a game. France
Don't
was
tell the
routed.
score. Don't tell the score because some people are here instead of watching.
Anyway, so, well, I'm just happy, and then I feel excused here for being, for showing up, having announced that I won't be able to attend the call. And then that's it. I hope to understand better what we're talking about and progress. Richard, how do you feel? What do you expect?
Well, I'm feeling late. Apologies, we were out of town visiting a daughter and took a little bit longer to get back than I thought. So, yeah, I'm looking forward to that. I did some extra reading this week to get a better understanding of V2, and yeah, let's carry on, and I'll catch up as best I can.
Thank you.
Okay,
Manu, would you like to take over?
no, not to take over. I just want to join. What you're saying is exactly what I think that it is that the whole principle is to recognize 2 things. The binary nature of information, and to accumulate information, it is a combination of those. So it's a 2 to the power of something. The second thing is that in order to be able to compute faster, it is, you know, people who do information discover that it is easier to have blocks that you can recognize. It's like a new alphabet. Let's say we have 1, 2, 3, 4, 5, and then we decided that 2, 4 blocks of 2, 4, etc., describing the same set had sense, and we give them sense. So instead of saying 1 plus 1 or 1 plus 3, we have a sense of adding those blocks of same dimension and making sense of them, or operating on them. I don't know if I'm wrong, Fred, but that's the lesson I got from it. It is to simply to identify an alphabet that is made of blocks. And I gave an example of a 16 of I distributed. I don't know if Fred saw it or Steve. So that is 16-bit. So you have a matrix like that, and every number can be expressed as a combination of that number to the power of something.
I think you
Let me
should
put,
have you cannot wave your hand and have us understand that one. You have to show us what you have in mind.
okay.
I'm
Can
gonna
somebody,
share,
Steve,
I'm gonna
can
share
you
the
share, can
chart.
you share what I said?
I will. I'm sending it, I'm sharing it now. This is what you sent. I'm gonna make it a little bit smaller so that everybody can see the whole chart. So this is what we were computing when Manu came in. We'd gotten down to 10. Except
We were at 13.
that's not 10.
We were up to 13.
It's what?
We were up to 13.
Yeah, we were up to 13. I like my chart better because it shows the power of twos at the top.
Okay, you can put it in the power of 2 at the top. The number of there. Sorry,
See, there's
can
the
you see
power.
that?
What's that?
Yes. Exactly. Can you see that you can take, if you take a square, you know, if you take 15, for example, that number there, 0 to 15. And then,
This number here, 15.
yeah, show you again my table, please. You know, I'm a little bit
Oh, your
confused.
table?
Yes.
Okay.
Yes.
There's your 15 that shows the hexadecimal.
Yes, yes. So that is my exact, what I outlined is my exact decimal.
Okay,
And
just hold on. Hold on, Manu. Go back to yours, Steve.
Yeah.
Yes. Okay. Now you see the column in blue on the right, column K, that says decimal.
Column K, it says decimal.
Says
Yeah.
decimal. Yes. Now you go to column L, you make it a bit larger, and you write hex.
Okay.
H-E-X. Hex. Okay, good. Now you go to the line number 3 on the hex column, line number 3,
Line number 3 on the hex column right
and
there.
you write okay, just the where are we?
I'm
Okay,
right
just the cell under hex.
Yeah.
Okay, now this is 0.
Okay. Did I do that correctly? You should
I
be
can't
seeing a
see
0 there.
0. Then the next under is 1.
Okay, let me just format everything here. Then we'll say 1 and 2 and 3, 4, 5, 6, 7, 8.
No, because then it doesn't correspond. 10 is A.
Oh, that's right. I broke it. I wasn't sequential there. So
Yes.
this should be an
Or,
8.
or maybe you make it sequential up to 15.
So I'll continue this all the way up to 15. It'll
Yes.
be his chart. All right, so then let me do this so I don't destroy the integrity of my chart. Let me just copy a chart over there. And I'm really sorry that Zoom gets in the way of everything. Move or copy, or say create a copy, move to the end. So we're going to call this the hex chart, GX. And then now we can screw up with this thing here. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay.
Now you missed the 10 is incorrect.
Did I miss the 10? I'm sorry. I should have gone 1. There we go.
10 is A.
Yeah, no,
I
not
know.
there.
I've got to
Not in
just
that
move.
one.
I got to move these guys.
Yes.
There we go.
Okay. Now, if you go on the L, you keep going.
Okay. 6, 7, 8, 9, 10.
A, no, A,
A,
big A.
yeah, B. B,
B,
C, D, E, F.
that's correct.
And now that's basically the chart that Manu
And
sent.
now that's hexadecimal. Yes?
Right.
Now if you put 31, you put under 15, you put
Okay.
31,
Okay.
31, and then you put 63.
Okay. You want me to keep going here with numbers?
Yeah,
All right.
63, 127,
120. Yeah.
and 255.
I
Okay,
see.
now
That's
you
one,
go on
that's
the,
one digit below powers of 2 up here, right?
yeah, because you start counting at 1.
Yeah.
You start counting at 0.
Yeah.
That's why you're there. Okay, so now if you go to 31 on the L column, the
You want
cell
to
on
hit
the right side of the L column, yes. What are you going to write there? You're going to have
2F.
15 times 2,
Right.
16 times 2 actually,
Oh, I
because you
see.
start.
What?
So that's going to be FF.
Oh, for-
Right here.
Now on the right side, on the hexadecimal column, yes.
I gotcha.
FF. This is going to be what, this one?
And that's going to be a 1?
No, no, no. No,
Okay.
no. Keep going, keep going, fill up the hexadecimal.
With G or with
Yes.
F?
Yes, 63. What is it in hexadecimal?
FF.
FF.
3s?
3F. And how about the next one, Lee?
Well, it's got to be 4. Oh, sorry. Lee, what's the next one going to be? It's 4F, dear. You have
And
2 F's here.
what's the next
You
one?
have 3 F's here. You have 4 F's here. What are you going to have there?
5?
5 what?
5F?
Yes.
Okay, now
Did
you
you
need
get
to
that,
fill
Ann?
up.
Why?
I don't
No.
understand. I really don't understand what we're doing. I just know that I know the trick. The trick is add another F because you're at 1 digit below a power of 2 here.
Yes. Now, let's fill up the rest of the, let's fill up the FF line in
1010. Yes.
binary. Now, Manu, you know how to do it. We're not teaching you.
No, I'm just saying I would just say let's fill it in 1 or 0s. That's all I said.
Oh, okay. Yes, one or zero. Okay. So
Okay, if I were
let's fill
going
this. Let's fill this up. Let's fill the F. Start with the
Yeah.
F. The F is the easiest.
the F is the, okay, good. Let's go. So the question is, how many 2s are in 15? There are 7 2s in 15.
Ideally, you don't go through decimal.
Aha.
Ideally, you forget about the decimal. What
Okay.
would be F?
F is 15.
No. F is not 15.
Can I help? Can I help?
Forget the decimal. What
Can
would
I
be
help
F?
without saying what it is?
What would be F in binary?
Can I help without saying what it is? Or should I leave it?
I think we should leave
Let me figure
leave
it out.
Anne, Lee, and Stephen
One,
work it out.
1111. Is it 1111?
No.
Yes, why?
Because it's 842 and 1 will be 15. 1111. 1.
Just
So it'll be, yep, 1.
I think that's 2, 3. Yes. So 1111 would be 15.
Mhm.
Would be F. So what would be in binary? What would be double F? FF in hexadecimal.
In binary?
In binary.
Good. So the question would be, how many 2s are in 31? That's the way I would start.
No, because you need to forget the decimal.
Oh,
You take that
Oh, you do-
one.
Are we
You
doing
shift
hex?
it to the left. Steve, this is a trick. You take the band of F, 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 you shift
Oh,
it to the
yeah.
left,
Yeah, I got
and
that.
everything else is 0 to the right.
Oh.
Because it's like going from 9 to 10.
It has ones all the way across.
It
Wow.
has
He's cheating.
1, 2,
He
3.
knows the answer in advance.
So it has 4 ones to the left.
Remember, computers will work with registers of 8. A full register of 8 is going to be FF.
Well, the way I would think it is, how many 16s are there in 31?
Yeah, but you're going through decimal.
Yeah.
Exact.
But I see what you mean.
Yeah.
Wow.
I don't see that.
You
Wow.
should not go through decimal. Now,
Yeah.
F, you need 4 horses locations to code 1F. How many horses location do you need to code 2F?
8.
8. So when you have F is 4 is 1 1 1 1, then 4F, how much what is that going to be in binary?
Well, you switched over to binary, but I mean, I would just do the same. I would cheat just like Manu said. I just
Yes,
take
but
one
don't
guy
No,
and put
you're
him
not
over.
cheating, Steve. When you have 9, how do you write 10?
Manu, let them work it out.
Yeah, because it's another 20, 30, 30. Okay, there's another 32. Yeah, 32 because E 2 to the power of 5 is 32. So you add, yeah, so it's across 6. I see what you mean. Okay, got it.
Yeah, but you're thinking like I'm thinking, and Fred doesn't like the way I'm thinking because you're still thinking binary. You know, he wants us to think hex.
Let her explain. Please. And go on.
I guess it's okay. I can't explain, but I can see the pattern there, right? Because the F is the 4 bits, right? The 4 bits.
Mm-hmm. Yeah.
I don't hear Fred saying yes.
One
You're
F is
asking
4
about,
bits.
you're asking
One
about
F
that
is
F
4.
value.
Yeah.
I'm waiting for hearing an answer, not some intermediate loud speaking, loud thinking. It's there's a difference between giving an answer and thinking aloud.
So okay, the first one, the 1F is 4 bits. Yeah. And then when you go into 2Fs, you have because the subsequent one is actually another 4 bits, correct? Yeah, it's another 4 bits. That means the subsequent one is actually 2 bits, and then 32 is actually 3 bits. Three
That's
F,
good.
sorry, 3Fs.
That's good thinking. Ann.
Yeah.
Actually, what's written is correct.
Yeah, because the 32 is actually two of the 4 bits. Yeah, okay.
Okay, Steve, instead of cheating, just you can use decimal now to verify the FF line. Verify if this is correct using the decimal.
So when I use decimal now, I'm not cheating because I'm doing verification. Is that what you're saying?
That's correct.
If I
Yes.
tried to solve a hexadecimal problem with binary in the beginning, I'm cheating. But now I'm just doing correlation.
Actually, it's not cheating. It's just sides.
Yeah,
No,
what?
it's sidestepping what you need to learn.
The problem is I can cheat, or I understand the powers of 2. That's the thing that really got me with this whole thing. I am not getting where the basis is for the hexadecimal at all.
Yeah, but that's what we're doing. So verify it. Verify double F.
Say again. Verify the binary the way I cheat.
Now the double F is written 1 1 1 1 1.
Right.
So
That's right, because
Now convert,
there's one 16.
convert 1 to decimal using the powers of 2 on line number 1.
I see. So 2 to the 4 is 8. 2 to the 3 is 6.
Is 8. You have the lines here. You have 1 in the 16 column, F column. There's 16
Right.
plus 8, 16 plus 8 plus 4 plus
Right.
2 plus 1.
I see.
Yeah.
So how much is that?
Well, the answer is right here. It's 31.
No, but that's not verifying. You need to obtain this 31 another way to
Yeah.
verify it.
And so that's why you're saying 8 plus 8, or 16 plus 8 plus 4 plus 2 plus 1 is
Yes,
31.
correct.
Yeah.
Correct. Richard, can you write down the triple F? Starting
The triple F.
starting with triple F into binary.
Well, if we're doing, where are we? Oh, okay. Well, two to the fifth is, what's that? Two times
It's 32.
2 to
yeah,
the 6th is 32 right there.
32. Oh, right. So then we're going to go 32, 16, 8, 4, 2, and 1. That should get me 63.
Yes. So that will give you 64 because we start counting at 0.
Right. Okay.
Okay. So that you would be 1 in column 2 to the 5th, 1 in column 2 to the 4th, 1 in column 2 to the 3rd, 1 in column 2 to the 2nd, 1 in column 2 to the 2, 2 to the 1, and 1 in column 2 to the 0.
So
Steve, can you write the string in?
I did.
Okay, thank you. Thank you. Perfect, Richard.
See, I can do the verification, Fred, but I'm not getting how you build it without. I want to go back to binary. So tell me how to get out of the binary trap.
Can I just want to address something here. Okay, because the wordings,
Yes, hold on a second. And Stephen just asked a question. I'm not sure I understood it.
Well, let's hear what Anne has to say, because I think her question or what she has to say is
Okay.
going to clarify my situation.
Yeah, I'm actually addressing what Steve is saying, okay? Because Steve, because I also don't think in numbers, right? So over the years, as I was exposed to people who think in numbers, and then the Mortensen math that came to me from this guy, mathematician Sandy Sanderson, he changed the way I looked at numbers. So at the end of the day, when you say cheat, the minute you say cheat and there's another word, then what you have done is it changes the way you look at numbers. All right, that's the main thing I want to adjust. And what I found was actually it's mathematician, they look for patterns. It's just patterns that they're looking for, and they create formulas. They create all the ways of calculating using symbols like multiplication and like roots, squares, all these. Because they saw the pattern. And because most of us who are not numbers people, we don't see the patterns, we cannot relate the symbols to the patterns. And so it becomes like a completely different language. So it's not cheating, it's actually patterns. Yeah. And when they found a pattern, then they figured a way to shortcut the process. They shortcut the process. So a simple thing like multiplication, when we went down the path, my God, we have to calculate. But actually, the meaning of multiplication is a faster way of adding. So in general, when you do multiplication, there are 4 operations, but the 4 operations you deal with only 2, which is addition and subtraction. But then multiplication is a faster way of adding, and division is the faster way of subtracting. So here I'm seeing the same thing, which is patterns, and that's why these numbers with the FF and all that, become significant because they created a pattern, and the pattern became a formula of sorts, right? And then for those of us who cannot see the pattern, then we look at it as, okay, shortcuts or cheating, you know, or like shortcuts, but they're actually patterns. So that I just wanted to address that. It's not a cheat, it's actually a pattern that you need to see. Am I
Right.
clearer in
I
that?
call
Right.
it I call it cheating because I was being facetious, because I get the powers of two. I'm not getting this hexa. I don't even
Yeah,
know.
it's a pattern.
Hexa,
And I think what they're doing is that both Fred and both, because I recognize how we teach in our school, right? Because my sister refuses to just give formula, right? So what Fred and Manu are doing for us is getting us through to fill this up. Then you will see the pattern.
oh, I got all that.
Actually, that's correct, Anne. Actually, it's not cheating. It's escaping the pressure of
Yeah.
staring at it until you understand it.
Yeah.
Because you have a shortcut that you figured out. If I go through decimal, this is something I know and I can do it. Whereas if I remove the decimal, and if you play the game at removing the decimal, then you're looking at the symbol that you don't understand until you spend the time to stare at them and figure out what the process, how does these things change from one to the next, and then you figure out how that works. And I think it's a lot better than giving you a formula that you can follow or telling you, well, if you find it easier, go through decimal. I think it's going through decimal just robs you. You're robbing yourself of understanding how this really works at a deeper level.
Right. My problem is I'm stuck on the powers of two. That is my problem.
Yeah, but no, it's not your problem. The problem is that you spend enough time to stare at the powers of two to figure it out. Now you need to
What?
do the same process, staring at it with the hex, and then you will figure it out. You spend the time. You did the work on the decimal, and you understand it. Now you need
Yep.
to do the work on the hex, and you will understand it.
And I agree with that. And when I did geometry, I had a teacher just let me make up my own language. As long as I did, as long as I put the legend at the top of the page, he was happy because I had trouble with the way other people saw things. So I have a weird brain. I just haven't figured out. I mean, I'm seeing some symmetry here. What I notice is you have 16 bits is normal break off. And this thing is stopping. There's 16, but it counts to 0. So we're dealing with 16 bits right there. Am I right or am
Yes.
I wrong?
Yeah, that's correct. No, you're not. It's not bits.
That's
It's
my
not
problem.
bits.
What
It's
is it?
4 bits. 4 bits.
Yes,
With 4 bits, you can encode. With 4 bits in, you can encode the numbers you can encode 16 different numbers
In 4 bits. By
with
using
4 bits. Yes.
by using hex code.
No, by using decimal. Then
okay.
those 4 bits, I can compress them using one symbol only in hexadecimal.
Okay. I can help out here. I can help out here.
Go for it.
Okay. Right, because I can recognize, because my sister's brain is an engineer brain. So the way she looks at numbers, they're always like, I was talking about the patterns, right? So these numbers 31, 63, 127, 255 became significant because the person who is doing this decided and saw it and said, look, all you need to do is, if you want to know the next number, when you put a 1 there, is 63. Because, okay, if you look at the 4 bits for 32, you look at for 31, you have 1, 1, 1, 1, 1. So if you add another 32, it's another 1. And then if you add another 128, which is actually the squares to the power of 7. So instead of they just added that in, and that's how they did the F. So the F is that you just add on the squares of the next power. Okay, so that's why these numbers became significant. So instead, actually, when they did it, they added and then only they wrote 63. What we are doing right now is put the numbers down and figure out how the 63 came about. But what they did in the initial days is when they had the number 31, 15 first, 15. So the next power is 16. 2 to the power of 4 is 16. Then the next significant number was 31. And then after that, they look at 2 to the power of 5. The significant number is 32. So when you add to the 31 is 63. So the 63 became significant. Because otherwise it was just another number. However, and so this became a pattern. Yeah. And what Fred and Manu did is gave us the number and let us figure it out. Whereas when they did it, the mathematicians, when they did this, they went the other way. They said 16. So, no, 15. The next one is 16. So it's 31 is another significant number. And they started doing this FF and FFF and FFFFF, etc. Correct? Does that make sense?
To me, it does.
Well, it makes sense, but I'm still stuck on powers of two.
If you don't look, okay, let's say you don't look at 31, right? You don't look at 31. You don't look at 31.
It's okay to be stuck, Stephen. It's
Yeah.
okay. It's not easy.
Yeah.
It's a new gymnastic to learn. So stare at it until the solution appears. The
Okay.
pattern will appear. You need to spend the time staring at it.
Okay.
Thanks, Anne. Are you done?
No, can I try one more thing? Can you
Yeah.
remove?
Yes, please.
Can you remove 31, 63, 127, and 255?
You want me to take those out?
Take those out. Take those out.
I'm going to put them over here because I like them.
Okay. So yeah, just take them out for the moment. So when you look at 15, right, which is up to F, right, 15, the total, right?
Yeah.
So now, okay, if I added another bit, right? I go to 2 to the power of 4, which is 16. So the number would be 31 straight away. Do you get that? 15, and then you do 16, which is the next bit, 5 bits, right? So that would be 31. So straight, can you see 31 total up?
Yes.
Well, I see
Yeah.
16 twice is 32 minus 1 is
No,
31.
no. Don't go that path. No. Try this again. Up to 2 to the power of 3, right? You have 1, 1, 1, 1, 1 is 15, correct?
Okay.
Yeah. And then if you add another bit, which is 2 to the power 4, and you put a 1 there, it's 16, correct?
Yeah.
16 plus 15 would be
31.
31. So then you put it into that box, 31. That was how they came up with these numbers becoming the FF thingy, yeah. And then now you look at 31, correct? There are 5 bits, correct? And now you look at the 6 bits, which is 2 to the power of 5. And the number is 32, correct? 2 to the power of 5 is 32. So when you have 32, then you add to 31, it gives you 31 plus 32 would be
Yeah, well, that's the 63.
63.
But
Yeah.
that's a multiple of 8 minus 1, and I understand that. See, my brain locks in the multiples of 8 minus
No,
1.
Anne just taught you how to multiply by 2. All you have to do is move the whole thing and add a 0 at the back. You move the whole thing to the left,
Yeah.
and you add 1 0 in the 2 power 0, and you have doubled the number. That's
I
the
do
power of
understand that.
computers. They don't need to calculate 2 times. They move stuff. They move your number, they shift it to the left, add 1 0, and it's
Well, I do
doubled.
understand
If
that.
you want to divide, you take away the last digit, you move it to the right, and you add a 0 or you add a 1 depending on the value of the last digit, because 1 or 0 doesn't divide the same
But
way.
all you're doing is describing binary again, because my brain does that. My brain
Yeah.
understands that.
Yes, but you can do it. You can do it with a hex. If you stare at it long enough, you'll find it.
Yeah.
I'm gonna have to stare
Steve,
at it.
Steve, the problem with math all these years is that people gave us like the prime numbers. They gave us the multiplication, all the answers, like all the multiples there, and they gave us the formula. And that was where the problem began, because the minute those things are given and they don't show us the thought processes of how it comes about, then we for those of us who don't just see math like this, we die there. So like I give an example with Pythagoras theorem. My sister doesn't just do a square plus b square equals like c square or something like that. She doesn't.
Right, a squared plus b squared equals c squared, yeah.
So what we do is we actually get the students to draw the triangles, right? And then they are the ones who do the calculation to get the formula. And then we make it, we increase the size, reduce the size, and you see that it comes down to this, it's similar in terms of the pattern, and that's how the formula comes about. So we go about it the other way. So I can see that the minute we put the 30, 31 and 63 and 127, 255, it goes out the window because the numbers were given to us. So it is more how they decided on how to see the pattern and shortcut the process and create the pattern. Let me rephrase it. Shortcut, they see the pattern and they create the shortcut, which is the formula.
Well, I'll tell you what, listening to you just now, what I suddenly saw for the first time was why a squared plus b squared equals c squared. And I'm going to show you what I just saw from what you said, but it's not helping me on hex.
Before we go on a tangent with something else, Manu has something to say.
Okay.
Me too.
Oh.
All right, then I'll just do this on my own. Go ahead.
This is to have Steve. This is to have Han. I mean Richard, because I'm hearing a little bit confused things. This is a cartoon.
Okay, hang on. Oh shit, I did it wrong. Hang on. Okay, wait a second. All
Richard,
right.
would you like to say what you want to say before we share that?
Probably. I want to go back to what Anne was saying.
Go
Yes,
back to what
please
Anne
go
was
ahead.
saying.
And the chart. So
Oh, you want to go
Go
back
back
to
to the chart too. You want me to show that chart?
yeah, that would be helpful, I think.
All right, really good. Hang on a second. I've got your visual captured, Manu. So we'll share that in a second. And here comes the chart. You should see that chart now.
Not yet, but yeah, okay. So what I was getting from Anne is that when we get down to F, we're at the 2 to the power of 2, right?
Yep.
And then when
But 2 to the power of 3.
2 to the power of 3, okay. So then she's saying, and when we jump to FF, then we increase the 2 to the power, so it goes 2 to the power of 4.
Right.
And we go to FFF, then we do it again, so it now goes to the 2 to the power of
5.
6 or 5. 1, 2,
Yes,
3,
correct.
4.
That's true. But that's this trick of just moving this.
No,
that's
wait a
correct.
minute. Hold on.
Okay.
So I'm at 2 to the power of the 4 in FF, and just help me with the jump to 3 Fs now is 2 to the power of
6.
5.
6, but somebody says 5. And I count 6. Anne says 6 and I count 6.
Okay, hold on. It's 6 bits, but 6 bits is 2 to the power of 5 because computer starts counting at 0. So it's 0, 1, 2, 3, 4, 5. 6 bits.
Yeah, correct.
So help me with why Anne said 6 then. So
It's
we're just,
not- it is 6 bits. That means you need 6 stalls to put horses or not put horses, but that corresponds to 2 to the power of 5 in decimal, because computers start
well,
counting
okay. So what we're
at
getting
0.
at is again, I go back to the 2 to the power of 2 at F, and 2 to the power of FF is 3 or 4. I think it sounds like it's now 3.
F is 2 to the power of 3, and you need 4 bits to encode it.
Okay, sorry, 2 to the power of 3. And the next one is 2 to the power
FF is of 4,
and
and
said
you need
4.
5 bits to encode it.
Yeah, no, okay. Now I was missing some numbers. So again, I
Yes.
go from 3 to 4 to 5 to 6.
Yeah.
And I get from FF to FFF to FFFF.
Yes.
You're talking powers of 2, or you're talking number of bits?
No, well, I'm talking the power of 2 and the power of 3 and the power of 4.
Okay.
I'm trying to follow what Anne was describing, and
Yes.
it really helped me jump from F at the 2 to the power of 3, then then FF takes me 2 to the power of 4, FFF 2 to the power of 5.
Yes.
And I was missing one of the numbers how she was adding it up, because she started with
Yes.
2. She went from the power of 2 to the power of 4 to the power of 6. And
Yes.
this now is very helpful. I go to the 2 to the power of 3 to 4 to 5 to 6 to 7 to 8 to 9, whatever.
Okay. So now,
Okay.
if we look at FFFF, 127 in decimal, in
Right.
hexadecimal FFFF, how would you encode it in decimal, in binary? It's a line 22. How would you encode line 22?
Well, then I would to the power of 3, 4, 5. I'm going out to to the power of 7.
You probably 2 to the power of 6,
22.
but you
Sure,
need 7
6.
bits. You need 7 bits to encode it. Yes. So what would be the value at column number D, line number 22? What would be the value there?
64.
No.
In binary, it can only be 0 or 1.
Well, it should be 1.
Yep.
Yes. And how about the next one? Steve, you can write. Yes, thank you, Steve. How about the next one on the right?
Well, it should, if I'm following it right, I'm going to start counting from 64 all the way down to 1, and I should get 127, so it should be 1, 1, 1, 1, 1.
Okay, that's correct. Good. Thank you, Richard. I think you understand it.
Well, I've got that part. That's the trick. I've got the trick. That fell out to me just in 30 seconds flat, and it's 1 digit short of the next power of 2. So
Yes.
that's easy for me because I got the power of 2s, and I got that. Okay. Manu's had his hand raised for a while.
Thank you,
he
Richard.
took it down. He took it down. He does have his thing. I would like to show the epiphany that I got from Anne's share, but Manu, you're muted, so as much as we love you, we can't hear you.
I say I have my thing. I'm just be waiting.
Yeah.
So if you guys are ready, I do it.
All right. So are you changing your chart, Manu, or?
No, I'm not changing my charge. I'm just adding for people to make it a lot easier to understand. I think that we've been talking a language that is complex. That can be very easy. Okay. Consider this in conjunction with the first one that we had.
The first one, what?
The first cartoon that you first showed.
From you.
Yes.
That
You
would
saw
be-
the way 15 was written. 15 was 1, 1, 1, 1.
Oh, I'm on the wrong chart. It's not the first, it's my chart over here.
No, the one that I emailed. That I.
Oh, the one that you emailed. Okay, good.
Yeah,
We can
this
do that
cartoon.
too. I don't know if cartoon is the right word, but I'm happy to use it. Okay, here we go. Your PDF.
If I say matrix, you say I'm complicated.
There.
Okay. Do you see F? The way it's written.
Yeah.
15.
F is 1, 1, 1, 1.
Mhm.
And when we say 15, remember that there's a cipher before that.
Mhm.
So 15 in decimal mean actually 16 positions.
Sure.
Okay. Now,
In the US, we call that cipher as 0.
yeah.
Richard, do you use the word cipher or do you use 0? in
0.
Canada? Yeah.
No, everywhere is 0. I just say cipher because we understand it that is not a nothingness. It is something. Okay. Now go to the second cartoon. So remember the F, the way it's written, 1, 1, 1, 1, 4 positions.
That cartoon? Hang on, it's not there. I probably should just share my screen. There we go. There's the cartoon. That's the second drawing.
Yes. So now you are on top there, you have 15, that is F. No, to have 31, that is a 32-bit, you shift down and you go to the left. Remember that that's the way you write 10. When you have finished, when you have fed all of the cases of your fingers, 0, 1, 2, 3 to 9, you shift left.
I totally understand that.
And then to go to 157, 27, you do the same.
Another 4.
And then you do the same for 255.
Sure.
So you see now how the computer does the thing. It's easy
No.
for the computer. It is shift down and left. It's a loop calculation. Okay. So you end up having this thing here, a block. You end up, all is summarized in translation and rotation. It is the basis of the thing. We've been studying in Bucky that the elementary movement goes into moving according to a line in front of you or turning. And most of the time is a composite of that. That's why you represented it. It can be represented in the matrix. Now, if you can go as far as you want, and then you line that, and then everything else is once you have 15, once you have the numbers, everything else is 0 or 1, depending on what you want to represent. So you can pixelize that, put it in something, and the machine will see it fast. So the pattern of F, as Anne says, was seen first. And now all you're doing is to multiplying the position, creating a tapestry of that F to mean something. So you take it, you move it, and then you fill the others. You color. To me, a primary school guy can understand this. To be truthful, if you put a guy in a room, guys that are virgin of all the complications that we have in life, and ask them to color and say, color this like this, and then do that, and then put a number to say that this was this and this, that, they will memorize it. And by the time they are 10, they will be computing in 32 bits. Instead of us, we compete in 2 bits. We, in our education, it's 2 bits. That's what we do. So you can also count the 2 to the power 1. I mean, you can explain, you can say that you are going into, you are expanding your range. It's like concentric spheres. You were at the beginning very simple in the middle, and then you are going out into space. If you go out into space, it becomes more complicated for you to see all the positions. So if I were like this, if I were a small, like a tennis ball, I can see it quickly. But if I become a soccer ball and I'm an ant, it's more difficult for me. You can also see to the 2 to the power of 0, 1, that's the binary, to the power of to the power of 0, by the way, is just me. To the power of 1 is me and you. To the power of 3 becomes systems. You can call it also a tetrahedron. 2 to the power of 4, 2 to the power of 5. You can look at it now as polynomial things. Polynomial means something to the power of that you combine. So as I think Lee said, or Anne, that mathematics is a language. For as long as we have understood the code, then we can communicate. Because I can tell you something in that condensed form. Mathematics were invented to condense information. Remember that it came when we had to count. Because life is happening all over. It's too much. We need to put gates to count. And that gate is the base, is 8 bits, 32 bits. We put a gate that can take this much at a time. We take them, and then we have this much has gotten. Say there is soccer match. If we're talking about the World Cup, and then there is soccer play in Philadelphia, another one play in Florida, another one play in Los Angeles, and we wanted to know the number of people that have attended the whole World Cup thing, we just say Philadelphia, through that gate, there were 100,000. Los Angeles, there were 50,000. Miami, there were 70,000. We had 270,000. Instead of sending somebody to New York to go and crunch the numbers or be at the gate to count, then fly him to Los Angeles. Do the same thing. Fly him to Florida, across the continent, do the same thing, and bring him back to Washington, D.C.
Take the chance to tell us how you feel and what your takeaway is, Manu.
I feel sad for France. I don't know what happened to France. I don't tell him the score, but I just say I feel sad.
Oh, don't tell the score.
Okay. Otherwise, I'm getting animated. And you
no,
can
frankly, I don't appreciate that.
Yeah.
Okay. Sorry.
No, I've not seen the match, and don't appreciate people telling me the results before I see it. And
France won then. France won.
I warned you before. So no, frankly, I don't appreciate it.
It's not good.
Sorry. It was not in.
I do not accept your apologies. I warned you before.
Yeah. The neuro research shows that the dopamine reaction, once one knows the score, it affects the whole thing. It's like telling somebody the movie before the movie.
I do not accept your apology.
It's not polite, and it affects the whole process.
It's rude, it's necroptony, and frankly, I'm not even disappointed from you because you show up 1 hour late. You talk for 45 minutes at the end of the call, and then you give the result of the score. This is unacceptable.
Yeah. So you were starting your takeaways.
No, he's done.
Manu.
We're done with him. Anne, how you feeling and what's your takeaway?
I'm so grateful, and thank you so much, Fred, for taking the lead on this to help us, and then for Lee and Steve for you to sit down and work on the numbers, right? Because the minute you showed me the first, Lee showed me talked about it, and then the minute you showed me the power, and then when we started looking at the numbers, it just clicked for me, and to take that time, which I've 63 years. I live on this earth. I know binary numbers, but I don't know binary numbers.
How many is that in binary? How old are you in binary?
Yeah, 1, 1, 1, 1. Yes, thank you. Yes. Uh, I think it's 2 to the power of 5. Yes. 1, 1, 1, 1, 1. Okay, thank you so much. I'm so forever grateful because, I've always wondered, people talk about binary, how great it is, and I've never seen its greatness, right? And people talk about the possibilities for computerizing. What? It never, in one morning of this is less than 2 hours, I understood something that my entire lifetime I didn't understand. So thank you very much. That's yeah. So that's my takeaway. And then over to Richard. Richard, how do you feel and what is your takeaway today?
Well, I think I'm feeling pretty good. I did some work last week as well, and I got comfortable with the 2 to the power of 2, and I was working with the example I had on what I searched for around 27. But what I was also able to get a better feel for as to how you turn the positive into a negative, and how you change, if you want, you flip the numbers and the zeros. And I still probably have to do some more thinking on that, but that was helpful in terms of looking at the positive side and the negative side. This evening, what was helpful to understand that, if I got it right, the 2 to the power of 2 combinations or patterns, up to is it 15, so that we get to F. And then you were very helpful, Anne, in sort of letting me now see that when I jump to double F, I then increased the 2 to the power by 1, and then triple F did it again, and so forth. And I have to look in my own mind as whether Manu's cartoon, in terms of shifting over to the left, gives me a quicker way of seeing the total number of ones in whatever the number is. So this is, I've come a long ways from where I was at the end of our last session last Saturday. So I'm very grateful for that. Where are we to? Lee? How are you feeling? What's your takeaway?
Well, I've got to admit that Manu, the last cartoon, as he called it, I really liked. The 15 equals 4 ones, 4 ones, 4 ones, 4 ones for each F. And I got that. It made sense going down to the left. And that was very good. And I appreciate Manu for that. Steve, what is your takeaway? How do you feel and what's your takeaway?
Okay, well, I am a little bit disappointed about the game score, and I just got to say that because I understand how important that is. I've studied neuroscience about it, and I appreciate a good movie and knowing and seeing the ending without surprises. So that's it. All right, look, I got the cheating. It's moving the 4 and going down the 4. I got that. That fell out of my head. I've got the powers of 2 really good. I want to share the epiphany that I got from Ann Share, because I have the Pythagorean theory down to a T, and I really understand this A squared. I learned it really, really well, and I've got to mute you. There we go. And so I got this, but it didn't dawn on me until where the a squared plus b squared equals c squared comes from. I think this is so exciting. So all of a sudden, all I got to do is add the other triangle down up here. This makes the square. And let's see, can I get this to show up? I can get it to show up. There we go. So I just take the stupid triangle, flip it over. Now I've got two A's, I've got two B's, and I've got two C's. And now all I got to do is get the square root of C, and I never understood that before. And until you said what you said. Now I'm suddenly understand a graphical concept of a squared plus b squared equals c squared. It's two flipping triangles stuck together. Hoo-wah. All right. And as long as they're right angles, we're in good shape. So that was a real epiphany for me, and I love that. I'm going to, what I'm going to do is I'm going to work on this chart thing because I understand the binaries, and the way I understood the binaries very easily was I put, I put this little chart together. So now my next challenge is I've created a third chart, and it's going to be my hex chart. And what I'm probably going to end up doing is screwing around with this column, and I'm going to come out with what I'm going to do, just what my teacher Fred tells me. I'm going to stare at this puppy, and I'm going to figure this sucker out. So that, because I called it cheating. I got to just move the damn thing over one block. As soon as there's 16 bits, you hit 15. So the next number is the next stupid quadrant. So I'm in real good shape there. I'm gonna sleep on that and figure out that hex chart, or else I'm gonna explode. Okay, good.
Okay.
So Manu, I'm sorry to speak so bluntly about it, but I think it's just really it's important when someone requests something that I grant the request. And so I'm going to pass it off to Fred. Sorry, and I love you, Manu, and I'm just sharing because I got it because it's my truth, and I'm sorry. Fred, how are you feeling, and what is your what are your takeaways tonight?
Thank you, Steve. Before we stare at something, forget about everything we said about double F, triple F, and 4F. We made a mistake. This is not at all how it works.
Are you serious?
I'm serious.
Oh, I love this
means...
because he just unplugged me and said, okay, now we're going to shoot you out of your escape pod. You're floating through the universe. Figure it out. I love it, Fred.
Yes.
Thank you. You're truly a jerk.
Yes.
Perfect teacher. It's what a teacher should do.
That should not stop you from staring at it and figure out exactly how that works.
All right.
But what we did is, I put a pointer in the chat about what mistakes we made, and I put a pointer which says FF. What is FF, and what is 11111?
Right.
And that is correct. So we got carried away, and we did not do it correctly for the hex, and so we have to redo it. And maybe Steve, would you like to stare at it until the light bulbs lit off, and then explain it to us all next week?
I promise. I'm willing to make fun of myself once again. No,
yeah, that's
it's
okay.
the way I learn. I don't feel
I've made a fool of myself, so next week is you.
Yeah. Yeah. And Manu, I want you to know that I appreciate the effort that you made, but I want to say that
I want you guys to know that I don't appreciate it at all, and that is it. Full stop. Bye. Okay, right.
Don't be so immature. Don't be so immature. Just breathe, Manu.
No,
breathe.
I am. Don't tell me to breathe. I am.
I'm inviting you to breathe. I can't tell you to do anything.
To never make mention that I come late to a call. He doesn't know the effort I make to be on this call. It's 5 o'clock. I cannot have a weekend. Sorry.
It's not about your effort to be on the call.
No, it is. It is about him too.
On the game,
No. You have been partial. This group is because
we got to go. We'll see y'all. Bye-bye, everybody.